Hello everyone, welcome to Vision Tech Solutions channel. This is lesson 2 of the CCNA Practical Lab series. So in lesson 1, I told you how to download and install the packet tracer, and we got familiar with different tools and devices that we have in packet tracer. Now in this lesson, we are going to start with the Cisco command line interface, or CLI, of routers and switches, and we will explore different modes that we have for the CLI of routers and switches, and then we will have a brief introduction to VLANs. So first I will open the packet tracer that we installed in the previous lesson, and then I will load a couple of devices into So this is the packet tracer we downloaded and installed. So we will start by loading one router and one switch. Let's go to the switches, and for example, I load one 2960 24 port switch, and also I will load one router like 29, let's say 11. So first of all, in order to connect to these devices, you can just click on the switch and then you go to the command line interface. What we are working this session to show you different modes of the CLI when you connect to the router for the first time, to the router or the switch. So as you can see, the switch has boot up. Now the boot up process has finished, and when you press enter, you go, actually the first CLI mode that we can see here is called the user mode. So this greater sign and the switch is in the user mode. So in the user mode, actually you will have limited access to the switch, and you are provided with a set of actually non-destructive commands that allow examinations of certain router or switch parameters. So actually in this mode you have very limited access, and you cannot make any changes to the switch or router. So in order for me to actually to work or to make any changes, to modify any configuration, so I need to change the mode and go to the privilege mode or exec mode. In order to go to that, so I type just enable or en, and you can see that the mode that I'm in, it has changed. So this mode, we call it the privilege mode or enable mode or exec mode. All of them are the same, and in this mode allows you for greater examination of the switch, and actually it provides a more robust command set than the user mode. And actually in the privilege mode you have access to the configuration commands supplied in the global configuration mode. So it means you can edit the configuration for the router, and the default actually privilege level for this mode is 15. So you can run some again limited commands like show commands, show run, show running config, but still if you want to do the configuration, you have to go to the config mode. So if I just type configure terminal, I go to the config mode, and you can see that the switch mode now has changed. Or actually if I now exit, and if I just type CON and press tab, CONF and press tab, it will autocomplete for me, and T and then press tab, it will autocomplete terminal, configure terminal. So In this mode, which is called the global configuration mode, is um, we can enter it from the enable mode, and it will actually provide us the complete command set for configuring the router. So whatever configuration we want to do, we can do from this mode. It's called the config mode. So as you know, each router or switch has some ports. So this is like the 24 port. So you can see different ports of the switch in the picture. So we have different ports. When we want to configure these ports, there is another mode which is called interface level mode. So I can enter this mode from the config mode. So right now I'm in the configuration mode or global configuration mode. And if I just type interface and just press GI for the gigabit Ethernet, these are all gigabit Ethernet interfaces. We have fast Ethernet interfaces, and we have also gigabit Ethernet. We have two gigabit Ethernet interface, and we also have fast Ethernet. So we have 24 fast Ethernet and 2 uplinks. Actually, these are the ports of the switch. So or even I can just put FA fast Ethernet, and if you go here, it is 01. For example, I go 01, and you can see that the config mode has changed, and now I can see IF for the, it just stands for the interface. I'm in the interface mode. So interface mode allows me to configure the interfaces, any changes to the configurations, for example, giving the IP address, or let's say shutting or no shut the interface. I can go to the interface mode. And actually, to exit, you just type exit and you go again to the configuration mode. From the configuration mode, if you press exit, you go to the enable mode. And from the enable mode or exit mode, if I press exit, I go to the user mode. Again, enable conf t. Of course, there is another mode which is called the router mode. If I type router OS1, actually we will discuss the routing protocols later, but oh, sorry, this is a switch. Actually, we cannot go to the router mode, so because this is a switch, but I will show you in the router mode as well. And there is something called line level or line mode. We will discuss about the configuration of telnet and export later, but if I just type line VTY 015, as you can see that we are in the line mode. We will discuss this later when we want to configure the telnet or console on the routers or switches. So the same console modes we have for the router. So if I go to the router, go to the CLI, so I can see that I have these interfaces. So I will just, this is the user mode. I enable, I go to the exit mode. Conf t, I go to the configuration mode, and gig 01, I go to the interface mode. So I said about the router because so you can see that now I'm in the router mode. We will discuss about the routing protocols, but this is something that we will see in the routers. So to sum up, I will show you. So we have, for example, on the router, we have the user mode, we have the privilege mode, then we have configuration mode, interface level, we have config router for example, if we want to uh, configure the routing protocols, and also we have the line VTY line mode. So this is another thing I wanted to show you. So the enable, we go to the user mode, configure terminal, we go to the config mode, interface, we go to the interface mode. By exit, again we go to the config mode, router RIP, we go to the router line. By entering line VTY in the configuration mode, we go to the line mode, and these are different modes that we have on the switch or routers. So now I want to talk about a little bit about the VLANs. What are VLANs and why we need to have VLANs in the network. Actually, VLAN refers to a group of networking devices in the same broadcast domain. And you know, the broadcast domain is a domain in which one system sends a packet, all the other systems receive that packet. This is called the broadcast domain. And usually when we a virtual LAN or VLAN is a group of networking devices in the same broadcast domain logically. So I will show you this picture, and you can see we have in the company we have two departments, sales and techs. And if we want to actually isolate the sales department from the tech department, actually we don't want all of them in one broadcast domain. We want to break the broadcast domain, so we have to create VLANs in order to separate the traffic. So we don't want to, for example, sales computer, when they send a packet, this packet goes to also the tech department switch. So we want to put them in different virtual LANs. That's why we create the VLANs. So that is the concept for creating VLANs in the network. And I will show you another picture. So how actually it works. So when we have so it doesn't matter where these systems are located, as long as they are logically in different broadcast domains or in different VLANs, we can control the traffic between these depots. So you can see that we have sales, tech, and leader department. So, and we have different subnets for each department. Sales is 192.168.1/24. The tech department is 192.168.2. They are in different subnets, and each subnet is mapped to a different VLAN. So which means the traffic from each department, so in maybe it doesn't matter where physically they are connected to the switch, but logically they are in separate broadcast domains or VLANs. And in order for these VLANs to be able to talk to each other, so we have to make these ports as a trunk. So between two switches that we have, so we should have a trunk, because if we have different VLANs, the packet will also include the VLAN ID. So if we have VLAN 10 on this side, wants to talk to one system which is in VLAN 10 on the other side, connected to the other switch. So we configure these as the trunk. Otherwise, all the ports are in access mode. So here, PCA is attached to VLAN 2. So add a VLAN ID 2, which will be added to this frame, which is coming from this system. and then this packet will go when it wants to go to the other switch. It will be tagged with VLAN ID and on the trunk. So the trunk is actually a link that can carry tag traffic, the VLAN ID. And from here also the same thing. So this switch and PCB, there is also a VLAN ID, and then it will be removed from the packet. Then it wants to go to the PCB. So that is actually the function of the trunk. So also, as you can see, when these two, for example, we have first floor and third floor, we have different VLAN same stack and leaders. They are connected to two different switches, and then they go to the one main switch. And there should be a trunk port configured between these switches in order for these systems to be able to communicate with each other. So as you can see here again, and there is one terminology called native VLAN. So native VLAN is the VLAN which is not tagged. Actually, there is no tag, and it will go on the trunk untagged. This is usually in the networks. VLAN 1 is the native VLAN. Of course, we can change it, and the switches will use actually Cisco switches support two different trunking protocols. One is called interswitch link, or ISL, and also IEEE 802.1q. So usually encapsulation, when the packet you put it in a VLAN, because it will be encapsulated, the VLAN header will be added to the frame, and it will use the IEEE 802.1q encapsulation for encapsulating the packets. So that is called the 802.1q encapsulation. There is a concept called native VLAN, and for native VLAN it is not tagged. Frames are not tagged. So that was a brief introduction to the VLANs, why we need VLANs. In the next video, I will give you a practical actually lab of how to create VLANs and how we can set up the inter-VLAN routing, like when we have different systems in different VLANs, how we can map the subnets to the VLAN, and how we can establish the inter-VLAN routing so different systems in different VLANs are able to talk to each other. I hope this video has been useful, and see you in the next video. Thank you very much.